Hi everyone. Notes 6.7 are on solving problems with exponential and logarithmic functions. So if you take a look at question number 1, we're going to apply what we learned about exponential and logarithmic functions to some real life examples. So in chemistry, the pH, which measures the acidity or alkalinity of a substance, is based on a logarithmic scale. A logarithmic scale uses powers of 10 to compare numbers that vary greatly in size. So for example, very small and very large concentrations of the hydrogen ion in a solution influences its classification as either a base or an acid. So the relationship between pH and hydrogen ion concentration is given by the formula pH equals negative log of H plus, where H plus is the concentration of hydrogen ions in moles per liter. So the first question asks us to find the pH if the concentration of hydrogen ions is 0.0001 moles per liter. Okay, so here, if I know that the formula says that pH is equal to negative log of H plus right here. So if the concentration of hydrogen ions is 0.0001, I'm going to replace that with H plus here. So here I'm going to try to find my pH. It's going to be negative log of 0.0001. Okay, and don't forget, if there is no base implied here, or if there's no base written here, it's implied that the base is 10. Okay, so I want to know 10 to the power of what is equal to 0.0001. Okay, so I know that this is equal to 1 over, this is the tenths, hundredths, thousandths, 10,000ths, so it's 1 over 10,000, or 1 over 10 to the power of negative 4. So that means that, 10 to the power of 4, sorry about that, so this is 10 to the power of 4, which means that this is 10 to the power of negative 4. So my answer here is going to be negative 4, but the double negatives turn into a positive, so therefore the pH of the liquid is 4. Okay? So now question B says the pH of lemon juice is 2. Calculate the hydrogen ion concentration. So this time, if I'm given that given the pH, I'm still going to use this formula here, this equation, where pH is equal to negative log base 10 of H plus. And here I know that the pH is 2. So I'm going to say 2 equals negative log of H plus. Well, I want to isolate this log right here, so I'm going to divide both sides by a negative. So I can say negative 2 is equal to log of H plus. Now, because there is an invisible 10, or it's a base of 10, I can do 10 to the power of, for each one of these pieces here, and I get 10 to the power of negative 2 is equal to simply H plus here, because this 10 and this log will cancel each other out, and I can just bring that H plus right in front. Okay? So now that I've done that, I'm just going to figure out what 10 to the power of negative 2 is, and that's 1 over 10 to the power of 2. Right here. So I can say 0.01 is what H plus is. So we can say, therefore, the concentration of hydrogen ions is 0.01 moles per liter. Okay? All right, then the last part of this question says, if the hydrogen ion concentration is a measure of the strength of an acid, how much stronger is an acid with a pH of 1.6 than an acid with a pH of 2.5? So let's find the concentration of the acid with a pH of 1.6 right here. So again, if pH is equal to negative log of H plus right here, I'm going to say 1.6 is equal to negative log of h plus. So negative 1.6 is equal to positive log of h plus. So that means 10 to the power of negative 1.6 is equal to, right here we can just say h plus, because I'm raising each one to the power, or 10 to the power of each piece right here, just like we did on this problem right here. Okay, so that's one acid. Then we've got another acid where we know that the pH is 2.5. So here I'm going to say 2.5 equals negative log of H plus. Okay, so negative 2.5 equals log of H plus, which means that 10 to the power of negative 2.5 is H plus right here. Okay, so I want to know how much stronger is one than the other. So I'm going to divide my two values right here. Okay, so I'm going to divide 10 to the power of negative 1.6 by 10 to the power of negative 2.5. And when I do my division, I always need to subtract my numbers. And when I subtract negative 1.6 minus negative 2.5, this turns into a plus. So I end up getting 10 to the power of 0.9. Okay, so I'm going to type that into either Desmos or a calculator, whatever you prefer. So let's type it into Desmos right here. So I'm going to type in 10 to the power of 0.9, and I end up getting about 7.94. So right here, I get approximately 7.94. So we can say, therefore, an acid with a pH of 1.6 is about 7.9 times stronger than an acid with pH of 2.5. Okay, and then all right, number 2 is talking about the Richter scale, which is used to measure the magnitude of, or the intensity of, an earthquake. So the Richter magnitude scale uses logarithms to compare intensity of earthquakes. An earthquake of magnitude 2 is actually 10 times more intense than an earthquake of magnitude 1. So if you look right here, the intensity of this is 10. Here, the intensity of this is 10,000. Okay, so if there's a magnitude of 2, then the intensity is 100. So that's why it's 10 times more if the magnitude is 2 than if the magnitude is 1. Okay, the difference between the magnitudes of 2 earthquakes can determine the difference in intensity. So if the average earthquake measures 4.5 on a Richter scale, how much more intense is an earthquake that measures 8 on the Richter scale? So what I want to do first of all is I want to figure out what the actual intensity is for each one of these. Okay, so if we have something that measures 4.5 on the Richter scale, that means that the intensity is equal to 10 to the power of 4.5, okay? And if we have something that has a magnitude of 8 on the Richter scale, that means that that has an intensity of 10 to the power of 8. And if I want to know how much more intense one is than the other, I'm going to divide them. And if you remember, when we divide, we need to subtract our exponents. So 8 minus 4.5 is 3.5. So I'm going to type it in my calculator, 10 to the power of 3.5, and I end up getting 3,162 approximately. So we can say this is approximately 3,162. So therefore, an earthquake with a magnitude of 8 is 3,162 times more intense than an earthquake that measures 4.5. And that's my answer to this question right here. Okay. All right, the last one that we want to look at is number 3. So number 3 says blue jeans fade when washed due to the loss of blue dye from the fabric. If each washing removes about 2.2% of the original dye from the fabric, how many washings are required to give a pair of jeans a well-worn look? And for a well-worn look, jeans should contain at most 30% of the original dye. Okay, so right here, we know that we've got a formula that we can always use where it's A equals the initial amount times 1 plus r to the power of t, but this time right here we're going to say to the power of n because it's the number of times that you're washing the pair of jeans. Okay, so right here our initial amount, it starts with, we're going to assume it starts with 100% blue dye right here, and we're going to say it's 1 and it loses about 2.2%. So I'm going to say 1 minus 0.022 all to the power of n. So that's what A is right here. So A equals 100, and if I subtract 1 minus 0.022, I end up getting 0.978 to the power of n. Now I want to know how long it'll take to get a percentage of 30%. So I'm going to replace the A with 30. So divide both sides by 100, we get 0.3. And to be honest, we could have done this without the 100 in front and just replaced the A value with this 0.3 right here. So if I get 0.3 equals 0.978 to the power of n, to get this n out of here, I need to take the log of both sides. So here I'm going to say the log of 0.978 to the power of n, but I can bring this n out in front right here. So I can say n log of 0.978. And then to get the n alone, I can just divide both sides by the log of 0.978. So let's go ahead and type that into Desmos right here. So I'm going to type in the log of 0.3 over the log of 0.978. And if you notice right here, our answer is about 54.1. So we'll say here n is equal to 54.1 approximately. So we can say right here, therefore, it would take about 54 washings to give the jeans a well-worn look. Okay, let me know if you have any questions. That's it for the video. Bye.